So today we are going to summarize the chapter 3, 4, and 5. First, we will talk about traditional query language. We'll go through some definition first. The relational algebra defines the relation between data, and it contains six basic operation, including select, project, union, cross product, difference, and intersection. And the SQL is divided into two major components. One is called data definition language, which is used to create, delete, modify a schema in database. The second one is called data modification language, which is used to query, create, and delete rows in database. Overall, the relational algebra is a formal query language, but it is not implemented in commercial database, but it is a core concept of the SQL. And the problem of the traditional database is that it didn't support the querying across the points, lines, and polygon. So the creation of the object-oriented programming helps the spatial database to handle this complex data type, as I mentioned above. With the help of object-oriented concept, we can support more operations such as containing overlapping subset intersection between spatial data types. So usually the computation of the spatial data type is more complex than the traditional one, and the data for the spatial data is usually more large, and the performance of operation depends on the disk, like how the head move inside the disk, and how the management works, like how to keep all the data inside the memory instead of keep swapping in and out between memory and disk. Also, how should our file be structured? Like we can store a file like inside a heap or hash structure by hash map or order structure by B tree. And there's a concept called clustering. The clustering is an idea of how the object stores inside the memory. And there are three kinds of clustering. One is called internal clustering, which means store the data inside the memory, which since the size of the object is less than a single page. The second one is called local clustering, which means we can store a group of related objects into a single page. The last one is called global clustering. Instead grouping all the similar objects into a single page, we store them into consecutive memory pages. And since the data stored in disk is one-dimensional, so our spatial data can be multi-dimensional. And so our task will become harder. So there are several ways to like mapping the one-dimensional data type to multi-dimensional data. So there are three methods I mentioned inside the book. One is gray curve. Second one is called Z curve. The third one is called Hilbert curve. And here is some picture of the Z curve and the Hilbert curve. Also, we also want to utilize the indexing to reduce our database operation time. So, like we can use a grid file to store a bunch of the objects, and this object will usually store in multiple in different rectangle areas. And the second one is called R3, which is multiple dimension a dimensional data structure based on B tree, and the idea of our tree is to split the data into several grids, and then we can, and then our parent node in our tree will have a greater area, and his sub nodes will like have sub area or some overlapping area of the parent. So, and the last one is called R plus tree, which is modified version of that tree. And the goal of the R plus tree is to minimize the operation in overlap problems. So now we are going to talk about the querying process. The way how spatial data querying works is divided into two steps. The first one is called filtering step. The second one is called refinement step. The first step will try to find the approximate spatial data object. So we can in the second step we will largely reduce the space we want to search. So for example, we can use R-tree to find a minimum boundary rectangle and together approximate objects. And the second step will load the approximate object and try to get the exact data. And the operation in step 2 is more CPU intensive. And now I'm going to the most important thing is the join operation, because it is the principal method while we're doing the data operation. So there are totally three methods mentioned. The first one is easy. It's called nesting loop. It's that we just use two while loop to find all the correct data. And the second one is called tree matching algorithm, which is based on observing the minimum boundary rectangles inside the R tree, and the time complexity depends on the query key and the rectangle relations inside the R tree. And finally, we have another method called partial-based spatial matrix join, which used unique ID and the swim line algorithm to do the join operation. And how the querying optimization works. So it's also important issues. So the querying optimization is divided into 3 steps. One is called logical transformation, which it will try to represent a querying string as a query tree, and we will use this tree to eliminate unnecessary operations. The second one is called decomposition, which will tear the subquery apart, or it will separate the spatial and non-spatial data. And the final step is called dynamic programming. So we need to compute all the possibility of our result and find the most efficient one. So to avoid the duplicate in order to avoid duplicate state, we use dynamic programming to catch the state we already visit. And beside the querying optimization, we will also have the evaluation step, and the querying optimizer will evaluate all the plans and execute the lowest cost strategy. And finally, we will have the chance. We will have the chance to merge subquery, all the subquery into a one query, or we can merge spatial data and non-spatial data together. So I think that's all for today. Thank you so much.